Hey, the chemical equation is our thing today. The chemical equation. What is a chemical equation? A chemical equation is a shorthand representation of a chemical reaction using chemical symbols. Okay, a chemical equation is a shorthand representation of a chemical reaction using chemical symbols. In the equation on the paper below, we're having hydrogen gas. Therefore, put gas there. Oxygen gas, put gas there, and then water. We'll just take it to be in gaseous form because it's from being formed. Therefore, hydrogen burns in oxygen to give us water. Okay, this is the reason why the test for hydrogen produces a pop sound. That pop sound is simply because water is formed and it puts off the flame with an explosion of a sudden shutting down of the flame. Therefore, what does a chemical equation tell you? What do you see when you look at a chemical equation, or what should you extract from a chemical equation? I'm going to bring out a few things that you should be seeing each time you look at an equation. The angle of views that a chemical equation can be perceived from. The first one is simply the number of species reacting. By species I mean molecules or atoms or formula units. Therefore, from my equation, I'm having one molecule of hydrogen reacting to one molecule of oxygen to give me one molecule of water. Is this equation balanced? No, it's not. So I have to balance it. Here oxygen 1, but here oxygen is 2. So I put a 2 here in front. Then I have to put a 2 even here on the first part here. Therefore, this changes everything because we are now accounting for matter. Matter can never be destroyed or formed, but it's only transformed from one form to another, more like energy. Therefore, this changes our definition. These are molecules. Therefore, I'll say you look at it from the particle angle of view. In our case, these particles are molecules because of it being involving covalent bonding. Therefore, two molecules of hydrogen react with one molecule of water to give me two molecules of water. Two molecules hydrogen, one molecule oxygen, two molecules water. That's the first angle of view of this equation, looking at the particles involved. The second one is simply looking at the masses of the species involved. Therefore, the second way of reading an equation is by looking at it from the angle of mass. Here, if I was to follow mass, 4 grams of hydrogen has a mass of 1. Therefore, there are 4 atoms in these two molecules. Therefore, 4 grams of hydrogen reacts with 32 grams of oxygen to give me 18 times 2, that is 18, 36. To give me 36 grams of water. Therefore, from the mass point of view, I can say 4 grams of hydrogen reacts with 32 grams to give me 36 grams of water. Therefore, the second way is by looking at mass. The third way is by looking at the number of moles. Moles involved in the chemical reaction. Therefore, in this chemical reaction, having 2, this coefficient represents the number of moles. There's a 2 here, there's a 1 there, there's a 2 here. Therefore, 2 moles of hydrogen reacts with 1 mole of oxygen to give me 2 moles of water. Therefore, the third one is by looking at moles. The fourth one is by looking at volumes. This one only involves the species that are in gaseous form, species in gaseous state or form. So I can easily say, here we say 2 moles, 1 mole, and then 2 moles. But when we go to volume, it would all depend on the conditions that you want to follow or that you're following. Is it RTP or STP? Therefore, STP is standard temperature and pressure. Therefore, STP is 0 degrees Celsius, 1 atmospheric pressure. Then RTP, which is room temperature and pressure. This is standard temperature and pressure. This is room temperature and pressure. Room temperature is 25 degrees, 1 atmosphere. Therefore, gases easily expand and they easily contract. Therefore, they are really affected by minor changes in pressure and temperature. So you have to state the conditions. Here, if we follow STP, remember at STP, 1 mole of a gas occupies 22.4 decimeter cubic of volume. And then at RTP, 1 mole occupies 24 decimeters or liters, decimeter cubic. Therefore, I would say if I follow RTP, I would say I'm going to follow this one, and you can still apply using that one. Therefore, if I follow RTP at room temperature and pressure, these are 2 moles. Remember, 1 mole occupies this much at RTP. Therefore, we say this is actually 2 moles. So we'll say volume reacting volumes is the fourth way of looking at equations. Therefore, we're going to say 48 decimeter cubic or liters of hydrogen will react with, this is 1 mole, therefore it's going to be 24 decimeter cubic of oxygen to give us 48 decimeter cubic of water. By volumes, we're going to say 48 liters reacts with 24 liters to give us 48 liters. Decimeter cubic is the same as liter, but the liter is capacity, while decimeter cubic is volume. Therefore, basically, that would be the angles from which you can view an equation before you even proceed to use it in anything. Remember to view it appropriately for you to simply solve correctly. Bye bye for now.